Making RAM using logic gates only. It turns out, building RAM entirely out of logic gates is actually possible. But before starting, I had to dive into some serious research. I learned about flip-flops and latches, used in electronics. These circuits will be main part of my project. In electronics, flip-flops and latches are circuits that have two stable states that can store state information. There are a lot of different types of latches and flip-flops. After doing some more research, I found the perfect latch for my project, the D-latch. It features a clock input that acts like an enable switch, allowing me to control exactly when data is written into memory. I found an online D-latch simulator that features all basic information for my project. I'm going to demonstrate D-latch working principle. To optimize the design, I've implemented a matrix configuration. This allows me to use a multiplexing principle to reduce the total I/O count from 16 pins down to just 10, significantly simplifying the hardware requirements. Before diving into the main schematics, I developed a system architecture map. This diagram outlines the functional flow of the project and defines how each component interacts within the system. My final build is a 16-bit memory system. It's featuring a matrix-addressed architecture. By using 16 D-latches and a MOSFET-driven address encoder, I've optimized the I/O for 8-bit data processing. Although simulation lag prevented a final live test, the schematic was successfully finished. So what went wrong? While the circuit is a success, it has two main limitations. First, storage capacity. At only 2 bytes, it's a proof of concept rather than a high-tech component, though it's perfect for a DIY logic build. Second, structural stability. The design is currently vulnerable to data corruption if multiple addresses are selected simultaneously. There are likely hidden bugs within the schematics that still need to be discovered before it's fully reliable. Thank you for watching.